All right. Hello, everyone. My name is Esko Pekkarinen, and my presentation today will be a brief update on what's been going with the Kactus2 project since ORConf last year. So would you kindly raise your hand if you already know what's Kactus2? Wow, that's a lot of people. Excellent. So, wow, what just happened? Sorry? Scroll up. Thank you. All right, so we'll quickly go through what's new, what's going to be in the future changes in the, let's say, the couple of next months. And for those who don't already know what's Kactus2 project, there will be a short introduction at the end of the presentation, and then we'll summarize it all. Let's do it the old-fashioned way then. All right. So first of all, last year we discussed one of the problems within IP XACT, that every memory and register is defined within the containing component, and they're viewed in isolation. And when you have a product that has tens or hundreds of components, you're going to have the trouble of defining what's the register addresses, what's the view of the whole product. So we came up with a new view within the Kactus2 tool, where we gather all the address spaces from the product on the left, all the registers from all the components within the product on the right, and then align them according to their addresses. So you'll get one view of the whole memory structure within the product. One of the new elements, the new IP XACT standard presented was catalogs. So we wanted to implement that within the tool. So now you can group your IP XACT descriptions into catalogs, and you can also have other catalogs as part of the catalog. So you could describe what IP is required in a specific product or specific IP if it's a complex IP, and it will be all grouped in one place. Next up, within a component, sometimes you have memory maps you don't want to be directly accessed from the bus interfaces. So the new standard introduced a concept called indirect interfaces, where you have the target memory map accessed through another memory map. And you write the data and the address within this memory map through the bus interface as normal, and then the indirect interface make sure it will end up in the indirect map into the address defined by the field address in these registers. Another thing you can do with this is you can redirect the data out from another bus interface into the next component. So there's been a lot of updates on the Verilog generator we had. Mostly it's on the var generation. It's been refined a lot. You can now have constant values into ports. And what you will notice in the user interface immediately is the file preview. So whenever you're generating multiple files, you might want to check what the result will be. So there's a preview for all the files. And we've been working a lot on the manual and the guidelines to help the users adopt the tool. We've done a lot of updates on instructions. We added 6 new tutorials that can be found on YouTube, just to get if you want to look how to do a specific task with Kactus, you will find them categorized by the task. We moved our whole code base to GitHub. This is extremely important to us in the sense that now the users can very easily help us patch it if there are issues or if they want to contribute to the code base. And one of the things that we've been wanting to do is that when people are using IPXACT and Kactus2, they often come up with issues in packaging their IP. So we wanted to start a forum for discussing these problematic IPs. So if the users don't know how to do something or they want to discuss what's the best way to do something, we wanted to start a forum for that. And this also serves as a place for sharing IPs you think that would be useful for others as well. So that's what's been going on since last ORConf. And next up, I would like to ask for your help in making Kactus2 even better. After we look at what's next. So what we are looking currently is that when you have a lot of designs, a lot of components within the product hierarchy, we need to have ways to configure it through the whole hierarchy. This, in a sense, is very similar to propagating parameters in, say, Verilog from the higher level module to the submodules. And we're looking how to make this as easy as possible in IPXACT. We're still working on the memory designer that I showed on the couple of first slides. We're going to add some of the missing elements, such as memory remaps. That's conditionally the memory maps may change depending on the component configurability. And we're going to look to refine some of the features. One I run into lately was that mapping the ports automatically needs to have some more help for the user. So currently, mapping the ports is somewhat tedious, but if we can make the auto-connect faster and easier, it will help a lot. So, anyone who's ever used Kactus2, who know the tool, I would kindly ask you to take a survey. We're looking to get a lot of feedback with the survey to make the tool even more better. And with the answers we get, we're looking to make another publication considering Kactus2. So if you could do this, it would be a great help to us. If you don't have your laptop or other devices with you, come talk to me later. Now, those of you who don't know what's the Kactus2, while those who already know and started to do the survey, right? We're going to have a short look what the Kactus2 project is. So originally, the problem we found with a lot of companies, they were doing their in-house tooling efforts, disjoint. There was, in small companies, there was this one guy who had to do all the tooling, and it would usually end up being a small script, and that got copied to his coworker, and he modified it a little and took it back to the original writer, and at some point it just wasn't meeting the requirements anymore. Another problem we saw at that time was some of the student projects. They made this IP or component that was really good for the specific task it was designed, but once they graduated and left the university, nobody knew anymore how to use it. So from that, we started the Kactus2 project, and we wanted to unite whatever the tooling efforts were among the other, the smaller companies, and we wanted to make it open source, so it's available for everyone. And to make this work, we needed to find a common format that could be used for IP exchange. So, looking at this, our base for the project was the tool has to be usable. The tools at that time were really difficult to use. They were really difficult to install. And we didn't want any one of the users to spend 2 hours trying to install the program, trying to see if it's useful, and then after all the effort trying to install it, they just give up. So we wanted to make it as easy as possible. We wanted to make the tool as usable as possible. We wanted to make it stable, so we thought whatever is in the tool must work, even if it means we're going to have less features what we could, but whatever we have there will be stable. We wanted the tool to be helpful. I'm sure you already know the problem that you're doing something with the tool, you're designing something, then you pass it to the next tool, and 3 steps later, your compiler or synthesis tool or something prints this huge error. And tracing that back to the origin will be really tedious, trying to find what actually caused the problem. We wanted to show the problem immediately as it arises. And last standing stone we started with was that we have to respect the standards. If we do our own language or we start extending the standard very massively, it's not going to work with other tools. So we have to stick to the standards we selected. And at that time, IPXACT was released. It was, at that time, somewhat niche, but it showed promise, and it was one of the standards that actually now is getting a lot of attention in the industry. So briefly, what is IPXACT? It's an IEEE standard for modeling or capturing the meta information about the IPs. And the idea is that we divide all that into the behavior, the structural, and the configuration. So all those are separated from each other. If you look at traditional HDL languages such as Verilog, you very often have all the configuration mixed with the behavior, mixed with the structure. So IPXACT wanted to separate these 3. And the standard has almost 800 elements, so we're dealing with rather complex standard. And to help people adapt to the standard, we wanted to make the tool as easy as possible. So if you're trying to learn all those 800 elements, it's going to be really tedious. But we wanted to make the tool so that it's very apparent what all the different elements are and what they're used for. And one of the points about IPXACT, it's not just another language or description. It's a methodology where you separate all those 3, the structure, the behavior, and the configuration, and it defines the tool interfaces and how the IPs are integrated together. And to briefly show you the intended design flow, so at the heart of the standard is the component. That's a single IP. And when you take a bunch of these IPs and you instantiate them and connect them together, you get what's called a design. And if you already have existing IP, say you have this Verilog or VHDL files, you can import them into the IP XACT. You can include the behavior in what's called a file set and files in IP XACT. And from all this, you generate all the documents you're going to need for your synthesis, development, documentation, compilation, whatever follows in the design flow. Everything is generated from this IP XACT standard, and this is the golden reference from which everything, whenever you go, you check what's defined in this, that you know that's correct, and whatever's generated will be could be overridden at any time due to a new cycle of generation. So the idea is that IP XACT captures the structure. All the behavior is in the HDL files, and the design configuration is done at IP XACT level, not in the HDL files or configuration files. It's all in the standard format or within IP XACT. So let's go for a very brief summary. So in the last year, we have introduced our memory designer, where you can have all the registers and their addresses within a product. You can have local memory maps for the address spaces. You can filter, compress, and otherwise manipulate the view of the addresses and the registers and the address spaces. We have added support for some of the new IP XACT elements for catalogs for indirect interfaces. We have updated the Verilog generation. We have a lot of new improvements for usability, and we've been working on the manuals, the tutorials, and added more guidelines for the users and the community in general. And that about wraps it up. If you have any questions, feel free to ask them. You can also find me here today or tomorrow and come discuss IP XACT, Kactus2, or whatever. No, currently not. That would be really good. Yeah, it's something we've been thinking about, but haven't gotten there yet.
Microphones everywhere. So thanks for the improvements on Kactus2. So how far are we now to use Kactus2 as a kind of a block level designer, like you would do in Vivado, kind of to do a block level design and kind of generate the wrapping Verilog files that essentially do the connectivity. You have a bus generation that's, I think, being worked on now. So how far are we in this?
So let me start by saying I'm not that familiar with Xilinx Vivado, but in general, you can do all that. You can define the interfaces for the components. You can connect all those together. What we have been planning on is what you said is some kind of a bus generator. So one kind of a downfall or problem we have with IP XACT, it doesn't handle very well these generic buses where you have, let's say, we want to have n connections of this kind. And that's something we've been looking at, and we'll probably have some kind of a generator for those, so you enter the parameters for that. I'm going to want 6 interfaces of this kind, and then it will automatically generate that for you.
Looks good. Thanks.
Yeah.
Hello. I just wanted to ask if you have some kind of library of components or something delivered with it, so that it is easier for
You can go to GitHub. We have some examples there. We're looking to expand that as well. But there are some examples already available there. If you look at the tutorials in YouTube, all the components used in those tutorials will be given in the example library.
Is there verification knowledge stored in this concept?
No, unfortunately.
Are you planning to do this? Like keyword for stimulus?
Not really. It's kind of outside the scope of IP XACT. What we could probably do is implement some kind of plugin for this kind of tasks.
Like monitors and drivers?
Maybe, yeah.
Just a quick reply to Raul's question about library. I have packaged a few IPXACT cores to proof of concepts to build open risk-based socks. So if anyone wants to have some more examples, I'm happy to provide that.
IPXACT has this concept of generators.
Not yet, unfortunately.
You briefly mentioned plugins. Is there a plugin framework for this? So if I have an in-house, say, memory generator tool or an in-house register generator tool, can I invoke it from Kactus?
We have a rather strict interface for plugins, but I'll be glad to discuss how to integrate your tools with our plugin interface. Yep. I'm sorry?
What does this memory designer do?
So it's basically, let me show you the slide. So if you look at the IPXACT components as they are, they're all defined in isolation. They all define their own registers, but there's no concept of this kind of global address. If you give the addresses in the component, they're so-called local addresses. They have this local offset for the registers. So in the memory designer, we gather all that. We go through the connections in the designs, and they may change the addressing. Let's say there's a bus component that changes the addressing. That's all taken into account when we create this view.
You basically generate the register mapping.
Yes. Yes.
No address map for the design, for the designer. Okay, thank you.
Tough questions, huh?
They're good questions.
Hey, also a quick question. So I kind of really like IPXACT, but the problem I've always had is that there's really seems to be a lack of tools to then generate RTL from it, right? And so are you aware of what is the current state? Like, is there any commercial tools available to do this, or is like Kactus the only thing out there today?
Well, to my knowledge, there's currently one commercial tool that's very expensive. There's Kactus2, and there's another freely available tool. I think it's called currently the Design Player or something.
So which is the commercial one?
Magellan. Yeah.
I think that all vendors have their own tools.
Yes, that's very common from what we're seeing is that they have their own tools.
I believe you have said that you don't have like an interconnect or generator or something like that.
Mm-hmm.
So I was wondering then, how do you map this like global design register map to something, or is it only a description that I get in the end?
So the subject we touched earlier is that you can have connections, you can have bus components, but the problem with the standard is that you cannot have generic components that say there's a parameter for how many interfaces you have in it, how many connections go out from that. But you can do the connections and the buses with IPXACT and Kactus2.
Maybe it's better we talk later.
Yeah, sure.
I don't know exactly what is the scope of Kactus.
Sure. All right, I think that's all. Thank you.